My name is Mikhail, and together with Ilgis we work in Gearbox protocol, and our talk more related to practical security stuff, because Gearbox is a lensing protocol, and literally we have this spring TVL about $400 million. So what we want to present today is the practical steps how you can really achieve security, and why we should not focus only on things like security audits or solidity development, etc. What we should build all together to make the whole secure supply chain, do any updates, and etc. Gearbox, as I said, is a lending protocol. It's a two-side protocol, and here you can see there are some passive lenders who provide deposit, and there are some borrowers who can borrow money and use them. But the biggest outcome of the schema, if we do not go into details, that there are a lot of moving pieces. So Gearbox itself interacts with multiple protocols like Uniswap, Convex, Curve, LIDA, etc., etc. And each interactions should be considered from security standpoint. If you have a lot of composability, if your smart contract system depends on different smart contract, you should build much more focused how it works and how to make the things works. And instead of that, if you think that if you can design the protocol and it's enough to achieve security, it's not true. As you know, the latest security breaches were related to front end, to DNS, even to social networks, when people start to post different phishing links and users go and occasionally lose their money. So in this schema you can see how complex sometimes you should consider the whole supply chain, not only the protocol, all third-party stakeholders like liquidators. You should take into account oracles, which you can't control because it's independent software. However, we know that Chainlink has a pretty good record, but even though we have in our practice one time when Luna were crashed, and Chainlink really provide incorrect data into the smart contract system. And in this case, if you depend on many different third-party things, the way what we want to talk today is how to build a system which could at least provide you comprehensive overview what's going on, because either scan is not enough. You can go across multiple explorers, but you can't to see the whole picture. And what practical steps you can do to understand how to achieve. We call this stuff, it's a Gearbox risk framework, and it's more like a set of best practices we recommend to implement for everyone who want to build a protocol which could be compromised, which could be attacked from potential hackers, or for people who will try to steal or really do something. And the first part I definitely recommend to everyone who start thinking about the protocol security is to write a list of all potential risks. It sounds pretty easy, but when even you design the protocol, you have a lot of things you can solve on the protocol level. For example, your price oracle could deliver incorrect data. And in this case, for example, in Gearbox, we use like two alternative sources of price data, and then we pick the minimum one to understand that the collateral done and computed correctly. However, we do not focus on protocol risk only. We really found and write all, not only risks, but suspicious behavior, and it's related to market risks themselves. If the prices could change very fast, it could also have some implications like liquidations and different stuff. And another kind of risk which do not take seriously related to front-end part. As you know, Curve was hacked using a DNS poisoning, when the guy from Namecheap company, if I remember correctly, changed the DNS and users go and provide approvals to incorrect websites. Another part you can also take into account that I think all of us use a lot of libraries for development. And literally, please hand up who check libraries when you get them from NPM or GitHub. No, nobody's here, but it's a big threat. So if you start thinking about the whole supply chain, you should be ensured that when you get any NPM package, when you get any library, they work as expected, because currently hackers implemented a lot of stuff inside the library, and the thing what we have seen that people launch on their machines, get a Trojans, and then got hacked. And another very good part is to build invariants for your protocol. Do you know what invariants are?
Like testing strange values?
It's a fuzzing testing. So invariants, literally, it's a rule which could not be never broken inside your system. For example, if you design a very simple explanation for token contract. For example, you want to design a very robust token contract. So the invariant for ERC20 token means that total supply always equal supply for all balances. Yeah? So if you go across all balances and compute, they should be equal. Otherwise, your protocol works incorrectly. It sounds pretty fun when you talk about normal and simple tokens, but if you have a little bit more complicated math inside the token, for example, you provide some interest rate, or maybe you mint them in a different things, this rule could save you a lot. And there are some good developer framework like Echidna, or I think Foundry itself has a fuzzing additional library to test the contracts. But one good implication of that, you should not only use them for test. You can simply build a monitoring system like a bot, launch it, and then you get all things, and you can do any consequences if something goes wrong, because the protocol invariant is the most significant part. There are many companies who try to build something like artificial intelligence security models, but they are really worse in comparison with invariance, because if invariance is broken, it means that your protocol works totally in different ways than it's designed. And another good part, as you can see, there is a screenshot of different bots we launch in our system, is to change dramatic changes, because all time when big hacks happens, it could be some predictors like huge deposits, or people do some continuous similar transactions. You can't understand any sense. For example, it's not applicable for DeFi only, any other protocol, even in privacy. If you can see people who try to do some brute force attack, it could be a sign that the team should immediately focus on what's going on. And of course, you should get all things immediately, what happens on your protocol, all significant stuff like pausing the protocol, any update, any transaction in multi-sig which could really provide anything else should be immediately get to Telegram bot. I think it's one of the most useful part, and then you can understand what's going on. But another very good question is how we can prove that the things work correctly, and people also sometimes do not pay a lot of attention to build a system which could help them to understand what's going on, and some kind of analytical tools. Because in terms of any risk event, you will be under pressure, and if you want to understand that things works correctly, you should definitely open it and check. And another good recommendation is to gather all together these informational sources into one system and then provide them into different categories. It's a very good to check. Some kind of events should be marked as alerts, and another is just notification. And if you can set up a policy in your team that you should respond immediately for any alert, you at least will be on the time. Because during the earlier hack, I just checked the Telegram at this time. It was a very, very pity when the team could do nothing, and we got messages that like 8 million stolen, 50 million stolen. If you are always on time, if you have a Telegram and at least some emergency key to pause the system or at least respond correctly, you can save a lot of time, money, and nervous system. And another good advice here is how to really simulate these processes, because never you want to think about how bad consequences could happen. People try to avoid all these thoughts about, I don't know, hack, death, any problematic stuff to discuss, because we believe, hey, we are so smart, we can build a good system, we write tests, and we are fine. But the reality is, and it was my experience, when you get, for example, Immunify bug bounty report with a critical finding. Yeah, so someone, as a white hacker, reported you that your protocol has a huge security threat. You have a very limited time to understand what's going on, and then you should make a decision. And if you do not really talk with your team members how to do that, you can be really in a problem, because in this case, you have a lot of different options how to respond, but you should make a decision under the pressure. And in multiple cases, while we learn this stuff, you have no access to information. You can't analyze maybe events. Of course, we have Etherscan, but it's not enough. We built our analytical system to check all transactions, to understand by graphs what's going on, to check the previous things happened in the protocol. And keep in mind that this response time is a key. So designing best practices for responding for any type of event is a very, very significant. And of course, it's good to simulate all these things and to understand what could happen. And in this case, I think it's a very interesting example I want to share. We use a system which is called optimistic liquidations. If your liquidations get stuck in lending protocol, it means that you can get bad debt and there are a lot of problems. For customers, they could not withdraw the money, they could not really do this stuff well. And in this case, we have a bot which each half an hour or hour launch a system, and it impersonates some parameters and liquidate all accounts. So we check that the system works perfectly because we have a pretty complex graph. It's multi-collateral stuff, so we can find all dependencies. And we want to check the ability that we can sell everything, and I just want to show a demo here. Oh. How it could be built, so maybe it's a little bit boring stuff. Oh, let me. Just. Oops. Sorry. No. No, I just want to show the system. Sorry. I will close the browser and open it one more time.
So basically, protocols integrate with your product in order to keep track of their security.
We track security independently. Oh my gosh. Как ты поправил это, Кис? Yeah, so here you can see a lot of information we gather. We have a few alternative liquidators. Also to achieve, if you can double any system, please do that, because otherwise you can get some incorrect information. And you can see there is an example of such kind of execution. It really shows the whole stats, how much it takes time, and you can go and check any problematic stuff. For example, this liquidate this account has a different problems, this pool has a different problems, and you can see the comprehensive information what's going on, and it's always enough for decision making because it happens during the simulation. So if you really could have potential problem, you can examine all this stuff before. And the next part, that if you want to deliver the system which could help you to manage your protocol safely, you can build a lot of stuff related to supply chain based on GitHub CI integration. For example, a very common problem related to front-end app safety and the possibility for someone to add a malicious code to the library. So it's a pretty bad case and it could cost a lot of money. There were a lot of things. So how to test your front end to make it to get a proof that your front-end app work as expected and nobody add a malicious parts. Because if you compare your node modules folder, it will be like a 1,000 libraries. There is no way to check how things happens. So we design a practice when we consider the front-end part as a just way which generate a transaction. You can consider it as a black box, your front end. You should not really check what's going on inside. Each libraries were installed or used. We use a testing framework which generates all user possible interactions. And we have a proxy provider from here which compare all things which were generated in front end and compare with expected behavior. So if in case of some hacker could implement a library, for example, which changes the address of spender in your approval transaction from your protocol to a malicious one. Yeah? In this case, when you provide the same user input as a test library, you will get a different transaction. So now you have a different transaction. This is correct transaction, and this transaction is malicious. And in malicious transaction, you will have a different address, which is not expected because you can hard code all this stuff and put it on CI in GitHub. And if you find a difference between the expected transactions and potential one, it means that one of your library inside your front-end application is compromised, and you should not deploy such kind of things. If you combine this practice with deployment stuff, you can get at least insurance that no one could implement any Trojans or any problem inside your front-end app. And also good practices is to create a fast track for emergency cases. It's what happened with Euler protocol. They could not pause the system. They could not make a fast update because they have a time lock of 6 hours or 24 hours. So some cases on the protocol level could be designed in a different role, like emergency role, which could really stop, for example, any pull, pause the part of the system, or forbid any actions. And the last but interesting part I also want to share, it's a process how we update the protocol. Last, I think, months, we got two big hacks. One was related to Radiant Capital, and it was hacked for 50 million. And another was related to the Morpha, when misconfiguration get less losses. It was only 230, but at least it's all-time problem. So just in our policy, we generate transaction on the 2 independent machines and then compare bytecode. Using create 2 addresses also improve your security. If you have even one change in your bytecode, the address generated by create2 will be different. It's a hash function, and you can find the difference between 2 machines. It's a very obvious. And of course, it's good to simulate any transactions before they come to the time lock and updatable system. And if you put them to really remove the cases what happened in Radiant Capital, you can impersonate your account and launch them one more time and check what's going on, how state will be changed. So you, in time lock, for example, you have 24 hours. You really start a fork. you really execute all transactions which were passed, it could really eliminate the problem with Radiant, because at this case you really apply all stuff which wait for execution, and if you can find any abnormal behavior, you can really start veto process into multi-sig to remove all of them. Very good things, like two last stuff, it's have a human readable transaction. Sometimes people do not really put all explanation, and if you try to analyze a lot of logs full of addresses, it's also impossible. The best way is to mark them, to copy decimals. It was a problem, for example, with Morpho. Each time you have a human readable format, it's much better, you can understand without these zero scales. And the last part I also want to show the demo is related to Cloud Testnet. It's a pretty cool feature we built. So each time before we even start any process, we have a Cloud Testnet based on Foundry and Anvil, and I definitely recommend to build a similar system. So we have an active forks, and active fork is like a fork of existing blockchain with when we really execute all transactions from the batch we are going to implement, and we launch a lot of tests. We also make it possible for all third-party integrations, which help us to test liquidation bots, front-end part, and etc. Because it's like, oh sorry, it's a little bit too much. And at the end, you can really get approvals for all third-party and involved other teams that everything works correctly, nothing is broken before it's going to the production. I think it's all. Sorry for a little bit technical issue. Thank you so much.